Lesson 7.3, Evaluating Expressions with Variables. In this lesson, we're going to see expressions where it's not just whole numbers and decimals and operations. We're going to see each expression is going to have a variable. And a variable, of course, is just a symbol, a placeholder. And in this case, if I was to take a look at this first practice problem, the variable a could represent anything. But to evaluate the expression means I'm plugging in a certain value for a and then performing the work of dividing it by 4/10. Let's get started. In this first example, the expression is a divided by 4/10, and we're asked to evaluate or solve the expression for when a is equal to 12. So imagine that we're plugging in this value for where you see the variable. And now I'm going to rewrite the expression as 12 divided by 4/10. Now, this can become long division, where the number I am dividing is the dividend that goes under the bracket. And how many ways am I splitting it or dividing it? That goes outside the bracket. Remember what we do when the divisor has a decimal point. We've got to clear it out. One push will do the trick, but what we do to one side, we must also do to the other side. So now I'm looking at 120 divided by 4. And maybe you can do this as mental math, but 4 goes into 12 3 times. 4 times 3 is 12. Subtract that out. Bring down my 0. 4 goes into 0 0 times. Multiply, subtract. We have our answer, 30. Number 2, 1 1/2 minus b for b equals 1/4. Let's replace the variable with this value 1/4 and rewrite the expression. 1 1/2 minus 1/4. We know when we're adding or subtracting fractions, we need a common denominator. So 1/2 and 1/4. 4 is the larger of the two denominators. Will 4 work for 2? It will. So let's rewrite 1/2 by multiplying the bottom and top of this fraction by 2. And rewrite 1/2 as 2/4. Now, what is 1 2/4 minus 1/4? 1 1/4. Number 3, 10 minus c divided by 5 for c equals 25. You can see we have an expression now with two operations, so we'll have to be careful to use the order of operations when solving it. Let's replace c with its value. 10 minus 25 divided by 5. Now let's simplify this expression. Subtraction or division, what's the higher rank? In this case, division. Let's do the division first. 25 divided by 5 is 5. So the expression gets simplified to 10 minus 5, which of course is 5. Number 4, d times 3 1/2 for d equals 8. Let's replace the variable with its value. 8 times 3 1/2. There's a few ways we can solve this. We can break this apart and think about this expression as 8 times 3 plus 8 times 1/2. Or we can convert this to an improper fraction and then multiply it out. I'm going to do it that way just for fun. So I'm going to rewrite the whole number 8 as 8 over 1. I'm going to rewrite 3 1/2 as an improper fraction. The denominator stays the same. The numerator becomes 2 times 3 is 6 plus the 1 is 7. Look for cross-canceling. The 8 and the 2 goes into itself once. 2 goes into 8 4 times. Multiply across the top. 4 times 7 is 28. Multiply across the bottom. 1 times 1 is 1. And we get a final answer of 28. Now let's just use mental math to check it against the other method. Let's pretend that we broke this apart. And then we did 8 times 3, which would be 24. And then 8 times a half, or half of 8, which would be 4. 24 plus 4 does indeed equal 28. It checks out either way. Number 5, 11 times the sum of 1 and e, where e equals 12. Okay, so I'm going to rewrite the expression. We know between these two operations, the parentheses work will be done first. Adding, in this case, will be done first. 1 plus 12 is 13. And now let's multiply this out. You may be able to do this as mental math, but you don't have to. You can set this up as a side calculation. 1 times 3 is 3. 1 times 1 is 1. 0 placeholder. 1 times 3 is 3. 1 times 1 is 1. And running out of space, get an answer of 143. Number 6, 182 divided by h times 3 for h equals 2. Let's rewrite the expression. Two operations here. Which comes first? Well, they have the same rank, but the tiebreaker is we're going to work them from left to right. 182 divided by 2 is going to come first. So I'm going to do that as a side calculation. 2 goes into 18 9 times. 2 multiplied by 9 is 18. Oops. Subtract that. Bring down. 2 goes into 2 once. 2 times 1 is 2. There. Nothing left over, nothing left to bring down. 182 divided by 2 is 91. Now, 91 times 3. Okay. Side calculation. 91 times 3. 3 times 1 is 3. 3 times 9 is 27. I got a final answer of 273. Number 7. Let's rewrite the expression, replacing the value of g as 4. So this becomes 4 multiplied by 1/4 plus 4 divided by 1/4. 3 operations. Of the 3, multiplication and division come before adding, and we'll do multiplying first, division second, adding third. So let's multiply this. Can you do this as mental math? 4 multiplied by 1/4. Well, if 1/4 is a quarter, what's 4 quarters? Ding, ding, ding. If you said a whole, you'd be correct. So this is equal to 1 plus 4 divided by 1/4. We're doing division next. What's 4 divided by 1/4? Well, imagine that you were making change for $4 and trying to get quarters. How many quarters would you get? It's one way to do it. If you want to see me work it out as a side calculation, I'd be happy to do that. 4 divided by 1/4 is like 4 over 1 times, flip what's on the right, 4 over 1. 4 over 1 times 4 over 1, 16. 1 plus 16 equals 17. In parentheses, 4/10 minus h multiplied by 5. We will do the parentheses step first, and then we will multiply. Let's rewrite. 4/10 minus 1/10 times 5. Parentheses step first. 4/10 minus 1/10 gets us 3/10 times 5. Let's do one push. Whoop. 3 times 5 is 15. And then come back in one spot from the end. Pew! To reinsert that decimal point. 1 and 5/10 is our final. And number 9, I divided by 8 hundredths, where I equals 4. Let's write that out as long division. We're going to need 2 pushes to clear this decimal point out of the divisor. Whoop, whoop. What we do to this side, we must do to this side. Whoop, whoop. Rewrite it as 400 divided by 8, and 8 goes into 45 times. 8 times 5 is 40. Subtract that out, bring down the 0. 8 goes into 0 0 times. 8 times 0 is 0. Subtract that out. Nothing left over, nothing left to bring down, so we have a final answer of 50. On to the word problems. Ella bought a salad dressing for $8 and 3 tomatoes for $T each. Write an expression for the total amount Ella spent. Okay. Well, the salad dressing was 8 plus, we don't know how many tomatoes, but it was 3 times T. Now let's evaluate it. If each tomato cost $2, how much did Ella spend? Okay, now this is looking very much like what we have done above. Let's substitute the value of 2 for the variable T. 8 plus 3 times 2. Here we're going to multiply first. 3 times 2 is 6. Now we're adding in the 8, the cost of the salad dressing, get a total of $14. 11. Melanie is 3 years younger than James. Hawa is half Melanie's age. Let J be James's age. Write an expression for Melanie's age. Okay, I was given a clue in the first line. Melanie is 3 years younger than James. So if we're saying James is going to be represented by J, she's 3 years younger. So I'm going to say J minus 3. Whatever J is, I got to take away 3 to get Melanie's age. B, write an expression for Hawa's age. Okay. Well, Hawa is half Melanie's age. This is Melanie's age, J minus 3. So Hawa's age is Melanie's age, J minus 3, but it's half of it. So I could say divided by 2, or I could say multiply by a half. It's half. Now, if James is 13 years old, how old are Melanie and Hawa? Okay, well, Melanie is 13 minus 3, or 10. Hawa is 13 minus 3, which was 10, times a half. Half of 10, 5.